The points P, Q, R and S lie in order on a semicircle with centre O and diameter POS. When angle ROS is 44 degrees and QRO is 47, determine the size of angle QPO. So what we really need is a picture. So if this is the O, and we know that POS is a diameter, then we can have P here, S here, and the centre O. Now Q and R will be on this semicircle as well, because we're told that P, Q, R and S are in that order on a semicircle. We're told that the angle ROS is 44. Well, that's this angle just here. We're also told that QRO is 47. So that's this one here. And we're wanting to find the size of this angle here. So let's call this one X. Now, we have a straight line here. So this angle just here must be 180 take away 44. So this angle here is 136 degrees. Then this angle just here is 360 take away 136. So that's 224 degrees. Now consider that angle and this angle. This angle here is the angle at the center subtended by this arc. And this angle here is the angle at the circumference subtended by the same arc. Therefore, the angle PQR is going to be half of 224, which is 112 degrees. So the angle we called X, the angle we're after, is going to be 360 because we're in a quadrilateral. Take away 112, take away 47, take away 136, and that gives me 65 degrees. In the diagram, DA is the tangent to the circle at A, and DCB is a secant that cuts the circle at B and C. Point E lies between B and C, so that the distance from D to A is the same as the distance from D to E. We want to prove that the angle DCA is equal to the angle DAB. Well, let's call DCA, let's call that X for the moment. And if I call this angle here alpha and this one here beta, then X is going to be equal to alpha plus beta, because X is the exterior angle of that triangle. The other way of doing that would be to say that this angle here is 180 take away alpha plus beta, and then of course X being on a straight line with that angle would be 180 take away 180 take away alpha plus beta, which would just give me alpha plus beta. Now, angle DAC, which is this angle here, is also equal to beta. That's because AD is a tangent, so I'm using the alternate segment theorem. And that means that angle DAB is equal to alpha plus beta. And we can see that on the diagram. We now want to prove that AE bisects the angle BAC. So AE is the line across here. What we're trying to show then is that this angle here is alpha divided by 2, so that it bisects the angle. Remember that in the information it said that AD and DE are equal in length. So we have an isosceles triangle. Now, angle ADC, which is this angle here at the top of the triangle, would be equal to 180 take away x, take away beta. And that's just using the triangle ADC. And we found that x was alpha plus beta. So that's 180 take away alpha, take away 2 beta. Now, angle DAE, which is this angle just here, is a base angle of an isosceles triangle. So if we do 180 take away 180 minus alpha minus 2 beta, which is the angle here, all divided by 2, and we can do that because we're working in an isosceles triangle. Well, that gives me alpha plus 2 beta divided by 2, which is alpha over 2 plus beta. So what we're saying is that this angle here is alpha over 2 plus beta, and we know this part of it is beta, so that means that angle CAE is equal to alpha over 2 as required.